We are going to start now lecture 13 of chapter 9 class 11th mathematics sequence and series. Now in this lecture we will solve certain more problems related to the sum of the series. So first question we have over here, we have to calculate the sum of this series. So if we look at the difference over here, the difference between these two terms it is 4, the difference between these two terms it is 13, then the difference between these two terms it is 40, the difference between these two terms it is 121. Now this is not an AP, so we calculate the second difference. Second difference means we are having 4, 13, 40, 121 and so on. Now difference between these two terms it is 9, next two terms it is 27, next two terms it is 81, and this is a GP. This is a GP, and the common ratio of this GP it is 3. So we are writing the value Sn is equal to, it is 1 plus 5 plus 18 plus 58 plus 179 so on up to plus Tn. Now we write the value of Sn again, So we are writing Sn is equal to 1 plus 5 plus 18 plus 58 so on up to Tn minus 1, and last term it is Tn over here. Now if we subtract both these values, we get 0 is equal to 1 plus 4, the next term we have it is plus 13 plus 40 plus 121 so on up to plus Tn minus 1, and last term we have it is minus of Tn. So we are getting from this result we are writing Tn is equal to 1 plus 4 plus 13 plus 40 plus 121 so on up to n terms. Again we are writing Tn is equal to 1 plus 4 plus 13 plus 140 so on up to n terms. Now if we subtract these two values, we are saying suppose the nth term we are writing it is Tn over here, the nth term we are writing it is Tn over here. So the answer on subtracting we obtain it is 1 plus 3 plus 9 plus 27 so on up to Tn minus 1 minus Tn. So the value, this value is equal to 0. So the value of Tn we obtain, that is 1 plus 3 plus 9 so on up to n terms. This is a GP with n terms, and the sum of this GP it is given by the formula. The first term over here it is 1, so it is A into the common ratio for this GP it is 3. So we are writing it is 3 raised to the power n minus 1 over 3 minus 1. So the answer we are writing it is Tn is equal to 1 by 2 into 3 raised to the power n minus 1. Now we have the value of capital Tn is equal to sum of 1 by 2 3 raised to the power n minus 1. This is 1 by 2 sum of 3 raised to the power n minus sigma 1. Now what is this 3 raised to the power n sum? We are talking about this value. This is basically we are saying 3 raised to the power 1 plus 3 raised to the power 2 so on up to plus 3 raised to the power n. The sum of n terms. So we are writing it is 1 by 2 into the first term we have it is 3 into 3 raised to the power n minus 1 over 3 minus 1 minus n. So the answer we obtain in this case it is 3 by 4, 3 raised to the power n minus 1 minus 1 by 2 n. So this is the value of Tn that we have obtained. This is the value of Tn, that is the general term over here we have obtained. Now next we are going to explain over here the method of differences. We are talking about the shortcut method to find the nth term of the series. So we are saying that if the first consecutive difference of the given sequence it forms an AP, then we can write Tn is equal to the nth term that we have, it is equal to A into n minus 1 into n minus 2 plus B into n minus 1 plus C, where A, B, C are the constants. and we can determine the value of A, B, C by substituting the value of n is equal to 1, 2, 3 and putting the values of these T1, T2, T3 term in this equation. Second, we are saying if the first term, the first consecutive difference of the given sequence, they are in GP, in this case we are saying they are in AP, then we take Tn of the form a r raised to the power n minus 1 plus bn plus c. We substitute the values of n is equal to 1, 2, 3 and from the values of T1, T2, 3, T3 we obtain the values of a, b and c. And in the third case we are saying if the differences of the differences computed in step 1 are in AP, then we are saying that the value of Tn that we have, it is a into n minus 1, n minus 2, n minus 3 plus b into n minus 1 into n minus 2 plus c into n minus 1 plus d. Again we substitute the values of n as 1, 2, 3, 4 and we can obtain the values of a, b, c, d by using these values. And the next case we are saying if the differences of the differences, the second differences we are saying they form a GP, then the terms we take, the Tn, the general term we are saying it is of the form a r raised to the power n minus 1 plus b n square plus c n plus d and the values of a, b, c they can be obtained. So we solve certain problems to make these things more clear. So the first question we have is find the sum of this series. So the elements we have it is 2 plus 4 plus 7 plus 11 plus 16 and so on. So if we calculate the difference over here, the difference of these two terms it is 2, the difference of these two terms it is 3, difference of these two terms it is 4, difference of these two terms it is 5. So this forms an AP. So we are considering that the general term we have Tn that is of the form a into n minus 1, n minus 2 plus b into n minus 1 plus c. Now if we substitute the value of n is equal to 1, we obtain T1 that is equal to 2 that is equal to c. Next if we substitute n is equal to 2 and we substitute n is equal to 2, we get 4 is equal to b plus 2. So this implies us that the value of b is 2. And last if we substitute n is equal to 3, we obtain 7 is equal to, when we substitute 3 over here, this value will become 2, this value will become 1, we are writing it is 2a plus 2b plus c. We are writing this is 2a plus 4 plus 2. So this implies us that the value of a that we have it is equal to 1 by 2. So the general term Tn we have that is equal to 1 by 2 n minus 1 n minus 2 plus 2 times n minus 1 plus 2. So this is the general term we have and we are writing it is 1 by 2 into n square plus n plus 2. Now if we have to calculate the sum of this series, we are saying sigma Tn that is equal to 1 by 2 sigma n square plus sigma n plus 2 times sigma 1. The answer we obtain it is 1 by 2 sigma n square is n into n plus 1 into 2n plus 1 divided by 6 plus n into n plus 1 divided by 2 plus 2n. And when you simplify this term, you will obtain the answer 1 by 6 n into n square plus 3n plus 8. So this is the sum of this series. Next is find the nth term of this series. So it is 5 plus 7 plus 13 plus 31 plus 85 and so on. So if we calculate the differences over here, the difference is 2, then 6, then 18 and the next difference it is 54 and so on. So this is a GP and the common ratio we have over here, the value of R we have over here it is 3. So we are assuming that the general term Tn is equal to a into 3 raised to the power n minus 1 plus bn plus c. Now if we substitute the value of n that is equal to 1, then we substitute n is equal to 2 and we substitute n is equal to 3. So we obtain 5 is equal to a plus b plus c. In the second case, we obtain 7 is equal to, when we substitute n is equal to 2, we obtain it is 3a plus 2b plus c. And when we substitute n is equal to 3, we obtain 13 is equal to 9a plus 3b plus c. Now, if we solve these three equations, on solving these three equations, we obtain the value of a is equal to 1, b is equal to 0 and c is equal to 4. So you can use any method to solve these equations. You will obtain the value of a, b, c in this way. So Tn you will obtain that is equal to 3 raised to the power n minus 1 plus 4. So the sum of n terms, we are saying the sum of n terms, that is sigma Tn, that is equal to sigma 3 raised to the power n minus 1 plus 4 sigma 1. This term we are saying sigma 3 raised to the power n minus 1, this is 1 plus 3 so on up to plus 3 raised to the power n minus 1. It is a GP and its sum is 1 into 3 raised to the power n minus 1 over 3 minus 1 plus 4n. So the answer we obtain that is equal to 1 by 2 into 3 raised to the power n plus 8n minus 1. So this is the sum of this series. Now next we have is find the nth term of this series. So it is 1, then 2, then 5, then 12, then 25, then 46 and so on. Now if we calculate the differences over here, it is 1, the difference we have it is 3, then difference we have it is 7, then difference we have it is 13, next difference we have it is 21 and so on. So this is not an AP or GP. Next, if we calculate the second difference over here, we obtain the answers as this is 2, next it is 4, next it is 6, next it is 8 and so on. And this is an AP. So we are writing that the Tn is equal to A into n minus 1, n minus 2, n minus 3 plus B into n minus 1, n minus 2 plus C into n minus 1 plus D. Now if we substitute different values of A, B, C over here, of different values of n over here, when we substitute n is equal to 1, we are saying we obtain the value of D is equal to 1. When we substitute n is equal to 2, we get 2 is equal to C plus value of D is 1. So this implies that C is equal to 1. When we substitute n is equal to 3, we obtain 5 is equal to, when we substitute this value over here, we get 2b plus 2c plus d. So we are writing this is equal to 2b plus this value when we substitute it is equal to 3. So the value of b we obtain that is equal to 1. Next we are saying when we substitute n is equal to 4, we obtain 12 is equal to, on substituting the value is equal to 4, we obtain over here the answer is 4 minus 1 it is 3, 4 minus 2 it is 2. So we get it is 6a plus over here we get it is 6b plus 3c plus d. This is equal to 12. And if you solve this value, you will obtain the value of a is equal to 1 by 3. So the general term we have in this case, we are saying Tn that we have to find the nth term of the series. We are saying it is 1 by 3 n cube minus 6n square plus 11n minus 6 plus n square minus 3n plus 2, then plus n minus 1 plus 1. And when you simplify this value, you will obtain the answer n by 3 into n square minus 3n plus 5. So this is the general term of this given series. Now next we have to calculate the nth term of this series. So the terms we have over here, it is 2 plus 5 plus 12 plus 31 plus 86 and so on. Now if we calculate the differences over here, the difference we have it is 3, this is 7, the difference between these two it is 19, the difference between these two it is 55 and so on. This is neither an AP nor a GP. The second difference when we calculate we get it is 4, then it is 12, then it is 36 and so on, and this is a GP, and the common ratio we have over here it is 3. So we are saying the general term we have Tn is equal to a 3 raised to the power n minus 1 plus bn square plus cn plus d. Now if we substitute different values of n over here, we substitute n is equal to 1, 2, 3, 4 and 5. We obtain different equations. We need not to substitute 5 over here, we are substituting up to 4. So we obtain the equations. First is 2 is equal to a plus b plus c plus d. These are the equations mentioned over here. You can substitute these values and you can check whether you are getting these equations or not. These are the equations that you will obtain. And when you solve these equations, you will obtain the values of a, b, c, d. So we can write the general term over here. We are saying that the value of Tn we have it is 3n minus 1 plus n. We substitute the values of a, b, c, d in this equation and we will obtain this general term over here. Next we have is the method of differences. So we are saying, suppose we have a series given and the terms they are T1 plus T2 plus T3 so on up to Tn minus 1 plus Tn. Now we are writing this is Sn is equal to this sum. Then we are talking about the first order differences. First order differences means we are talking about difference of these two, we are writing it is delta T1. Difference of these two we are writing it is delta T2, and continuing in this way difference of these two we are writing it is delta Tn minus 1. Then we are talking about the second order differences. Difference of these two we are writing it is delta square T1 so on up to delta square Tn minus 2. This is 2 over here. So we are saying the general term we have in this case, the general term if we have to write, then it is written as Tn, the general term, it is n minus 1 C0 into T1 plus n minus 1 C1, the first difference of corresponding to 1, then plus n minus 1 C2 delta square T1 and so on up to plus n minus 1 C n minus 1 delta n minus 1 T1. These all values, these are n over here. These all values we have, these are n over here. And the sum of these n terms it is given by Sn is equal to nc1 T1 plus nc2 delta T1 so on up to plus ncn delta n Tn. So these are the values that we have, and where these differences, these we have already seen, these are the values of the differences if we continue in this way. So this method will be more clear to you with our next example. So the question is, find the nth term and the sum of n terms of this series. So if we write these numbers, it is 12, 40, 90, 168, 280 and 432. Now if we calculate the first difference over here, the first difference that between these two numbers, it is 28, then between these two numbers it is 50, then between these two numbers it is 78, then the next difference between these two numbers it is 112, then the difference between these two numbers it is 152. So these are the first differences. Now the second difference we have over here, the difference between these two numbers it is 22, the next difference we have it is 28, the next difference we have it is 34, the next difference we have it is 40. Next, the next difference between these two numbers it is 6, between these two numbers it is 6, between these two numbers it is 6, and rest all the differences they are 0. So we are basically interested in calculating the nth term, and the formula of nth term we know, it is Tn is equal to 12 into n minus 1 c 0 plus, look at these terms over here, we are interested, these are the coefficients we are having right now. Next we have is 28 into n minus 1 c1 plus 22 into n minus 1 c2 plus 6 into n minus 1 c3, and next all the terms they will be 0 because coefficients they are 0 over there. So if we calculate these values, if you simplify these values, the calculation these are, this is the value of Tn we are saying, and when you simplify these terms, you will obtain the final answer in this form, that it is n cube plus 5n square plus 6n. Similarly, if we have to calculate the sum of these terms, we are saying Sn, so that will be 12 into nc1 plus 28 into nc2 plus 22 into nc3 plus 6 into nc4, and when you simplify this value, this is the value of Sn that we have, and when you simplify this value, you will obtain the answer in this form. So this is the general term, this is the general term, and this is the sum of the n terms of this series. Now next we are going to solve the series or find the sum of the series corresponding to these two forms. So in the first form, we are saying we have the terms a1, a2, a3, ar plus a2, a3, so on up to ar plus 1, and an plus 1, so on up to an plus r minus 1. This is the first form we are going to discuss. So we are writing that let Sn, that is equal to a1, a2, so on up to ar plus a2, a3, so on up to ar plus 1. And if we continue in this way, we are saying that nth term we will have it is an plus 1, so on up to an plus r minus 1. This is the nth term that we will have over here, it is plus. Now let us suppose that the value of Vn, writing Vn is equal to an plus 1, so on up to an plus r minus 2, an plus r minus 1, and an plus r. That is, look at this nth term over here. We have taken an extra factor in Vn. Now if we write the value of Vn minus 1, the answer we are getting it is an minus 1, an, so on up to an plus r minus 2, an plus r minus 1. We are having this term over here, it is so on up to this. Now if we subtract these two values, we are saying we are calculating the value of Vn minus 1. We can write all these terms common, it is an plus 1, so on up to an plus r minus 1 common. We are left with is an plus r minus an minus 1. So what we obtain is that Vn minus 1, that is equal to Tn into an plus r minus an minus 1. Now suppose the common difference that we have for this AP, A1, A2, A3, so on up to n, the common difference we have it is D. Then what we have is the value of these terms, if we substitute, it is equal to Tn into A1 plus n plus r minus 1 D. This is the value of an plus r minus a1 plus n minus 2 d. So on solving this, what we obtain is r plus 1 d Tn, this value is equal to this, and this implies us, yes, in this value, this is equal to this. So this implies us that Tn is equal to 1 by r plus 1 into d into Vn minus 1. This is the value of Tn that we have obtained. Now we have to calculate the value of Sn, that is equal to sigma Tn. So that will be equal to 1 by r plus 1 into d sigma Vn minus 1. We are saying this is n is equal to 1 to n is varying. When we add these values, it is V1 minus V0, then V2 minus V1, so on. So when we add all these values, this V1 gets cancelled, and finally what we are left with is 1 over r plus 1. The value of d it is a2 minus a1, and the answer we are left over here it is Vn minus V naught. So these are the terms that we already have. These are the terms that we already have. So by using this result, we can find the sum of this series. We solve these problems based upon this method. So first is, we are calculating the sum of 1 into 2, 2 into 3, n into n plus 1. So we are saying that it is just like the value of r we have, it is 2, and it is sum of a1 a2 plus a2 a3 so on up to plus an minus 1. The answer we have seen, it is 1 over 3 into a2 minus a1 into an plus 1 an plus 2 minus a naught a1 a2. We have the formula, it is 1 over r plus 1. R plus 1 is 3 over here. Then it is a2 minus a1, and then we have it is Vn minus V naught. In Vn and V naught we have added an extra term over here. These are the two terms that we have added extra. So these are the values. So if we substitute the values of this question, it is 1 into 2, 2 into 3 into this, in this formula, we get that the sum of this whole term, that is equal to 1 by 3 into n plus 1 into n plus 2 minus 0 into 1 into 2. So the answer we are obtaining, that is in the form n into n plus 1 into n plus 2 divided by 3. Now similarly, we are saying if r is equal to 3, we will have the value, the sum in this form. The sum we have, it is, this is the formula for the sum. Now second form we have, it is, again we are considering this a1, a2, ar, these are all in AP, and we are having the terms as reciprocal of these terms. So we are saying, what we are talking over here, the general term we are having, it is in this form, Tn. Now the value of Vn we are writing in this form. In the previous case we have added an element, in this case we are leaving first factor from the denominator of Tn, and Vn minus 1 we have obtained in this form. Next step we are going to do is, we are going to calculate Vn minus 1, and on solving this we obtain the general term in this form, that it is Tn is equal to Vn minus 1 over d into 1 minus r. Again when we add all these values, we obtain the general formula of the sum, it is 1 over d into 1 minus r Vn minus V naught, and this is the final answer that we obtain in this case. So the only difference is that when we are talking about the sum of these terms, we were writing Vn by adding a term over there, but in this case we are not adding the term, we are leaving the first factor from the Tn, and we obtain Vn, we calculate the value of Vn minus 1. Rest the procedure is same, and we obtain the sum by using this formula. So we have mentioned the results for different values of r. We are saying for r is equal to 2, the sum of this series, it is given by this formula. When r is equal to 3, the sum of this series is given by this second formula. For r is equal to 4, you can substitute the value and you will obtain the answer in this form. And by using this result, you can verify, you can check at your own, that the sum of this series, that is 1 by 1 into 2, 1 by 2 into 3, 1 by 3 into 4, so on up to 1 by n into n plus 1. The sum we have, it is n over n plus 1. Similarly, for this series, the sum we have, it is 1 by 4 minus 1 by 2n into n plus 1 into n plus 2. And similarly, if we have 4 terms, this is example given over here, that the sum we have it is in this form. So these answers you can just obtain by substituting the values of n, a1, a2, a3 in these formulas. So you can remember, if you can remember this formula, it is well and good. Otherwise, you have to use the detailed method to calculate the answers. Next we have is find the sum up to n terms of this series. So if we look at these terms, we are writing the nth term we have Tn, that is equal to the values, the first terms it is 1, 4, 7 so on. So we are saying the nth term of the series 1, 4, 7 so on. So that will be equal to 3n minus 2. Then we are saying the nth term of the series 4, 7, 10 so on. So the nth term of this series will be 3n plus 1. Next we are saying the nth term of the series 7, 10, 15 so on. And the nth term of this series it is 3n plus 4. And last we are saying the nth term of the series, the terms we have it is 10, 13, 16 and so on. And the nth term we have it is 3n plus 7. So we are saying this is the value of Tn that we have. So if we write the value of Vn, we are adding an extra term to it. We get it is 3n minus 2 into 3n plus 1 into 3n plus 4 into 3n plus 7 into 3n plus 10. If we write the value of Vn minus 1, we get it is 3n minus 5 into 3n minus 2 into 3n plus 1 into 3n plus 4 into 3n plus 7. So what we obtain from these two values is, we are getting Vn is equal to 3n plus 10 into Tn, and Vn minus 1 is equal to 3n minus 5 into Tn. So if we calculate the value of Vn minus 1, we obtain the answer, it is 15 times Tn. So the value of Tn we obtain it is 1 by 15 into Vn minus 1. So if we calculate the sum over here, we are saying Sn. So that is equal to 1 by 15 sigma Vn minus 1. So this is equal to 1 by 15 into Vn minus V0. And if we substitute the values over here, we obtain it is 1 by 15 into 3n minus 2 into 3n plus 1 into 3n plus 4 into 3n plus 7 into 3n plus 10 plus, we have the product of the terms, it is minus 2 into 1 into 4 into 7 into 10, and the product of all these values we get it is plus 560. So this is the sum of this series. So it is up to you that how you want to calculate the sum of these series.